Welcome again, guys. So this is basically the last, VHDL lesson for this week, in which we're gonna explore the design of T flip-flop. Okay, it's really very simple design. Okay, so we have two ways, actually three ways to do it. Two of them is basically hierarchical ones, structural ones, using other components that we basically built so far. Or you can just describe it using if else statement, just like the JK. I'm gonna show you both now. Okay, but the really, the most or the easiest one is using the structural model. So we explored last time the JK flip flop, and basically T flip flop is a JK, but J and K are just equal to each other, wired, shorted. That's basically what we have that we're gonna do right now. So I built a package out of the JK. So it's become a package. It become a box for me that I can use anywhere else, and that's what I have done here. So basically, I have here the T flip flop design. Here is the inputs and the outputs. The inputs are the T input, which is basically will go to both inputs of the JK because they are equal. The clock and the reset, and the output is Q and Q bar. Okay. And here it is, just one line, includes the JK flip-flop package, the one that we designed last time, and just, include it in your design here. JK flip-flop has four inputs, J and K. Here are the J and K. So I'm connecting the same input T to both J and K, just like this one here, the design here that we see on the screen. Okay. Then the clock, same clock, same reset, and same outputs, Q and Q bar. Okay, so let's now check the test. The test bench is also, very similar to the JK one. Okay, I didn't change much. I just have one input now, so no need to write J and K with different values. This doesn't work here. Okay. So let's check now the output. So we have here some random, random states for the T, and we're gonna check what's gonna be the output Q. So in the beginning, as usual, I'm resetting the circuit to start with, with a good start, with a known start to avoid any problems in the simulation. So I make my reset 1 here for the first 2 nanoseconds. That's why the output Q is 0, and of course Q bar is 1. Then we will start at that point, 2 nanoseconds, the reset go back to 0, so the circuit will go back to its normal operation. I mean, it will become T flip-flop. It should behave like a T flip-flop. So with the first arrival of a first positive edge at 4 nanoseconds, this one in here, look, the value of T is 1. 1 means complement, toggle. That's, by the way, called the toggle flip-flop, because it always toggle when it's 1. So the Q was 0, so it will become now 1, because T is 1, and of course Q bar will be 0. No change here. It's a negative edge. Here it's a positive edge. T is again 1, so we're gonna toggle again from 1 to 0, and the Q bar from 0 to 1. Again 1, another toggle. Let's check a state. Yeah, this state here, the positive edge came, and the T is 0, so no change. Look, 0 will be just stay 0. 1 for Q bar will stay 1. Okay, guys, that's basically, the first way to design the T flip-flop. I didn't do the second way, and I will not assign it to you as a homework, but we're gonna look at it here in the design of the JK. Because it's basically a JK, but J and the K are always equal to each other. So what you're gonna do, if you wanna do it in this way using if else, it will be just one if. So you're gonna remove these two states in which J and K are not equal. J is 1 and K is 0, or J is 0 and K is 1, and just keep this state here. Okay, that if T equal to 1, then QQ assign not QQ to QQ, and assign not QQ bar to Q bar. That's it. no other, no other lines. Just one if state, no else even, So you have in the beginning, if reset is equal to 1, then reset Q, make QQ is equal to 0 and QQ bar equal to 1, okay? Then else if rising edge of the clock, then if and if, no else. In this case only, and this will be T equal to 1. That's basically if you want to do the T flip-flop in using this such kind of statement, the process statement, and if else, okay, or if end, or if statement basically. Okay, guys, that was basically the T flip-flop. Thank you very much for watching this video, and see you in the next video. Bye-bye.